Man and his flying machines have made growing demands of one another ever since powered flight became a reality. Today, those demands are tougher than ever. From the world's military authorities comes the need for flight crews totally integrated with their advanced technology aircraft, confident in tactical maneuver, skilled in the coordination of flight and weapons systems. From airline operators comes the need for the safe and efficient utilization of their aircraft, for flight crews to convert rapidly to new or different aircraft types as they're introduced into service, and for routine regulatory checking to be handled thoroughly without disruption to carefully coordinated operating schedules. The demands may be different, but civil and military operators are united in their belief that simulation has a crucial role to play in meeting these various needs. And that role is growing because in recent years, the dramatic development in digital computing technology has been combined with its application by the simulation industry. And this has meant that the performance of aircraft and the machines which represent them has been brought ever closer together. Not so long ago, a flight simulator was a device which mimicked the aircraft it represented as closely as early computing, electronics, and hydraulics allowed. Now, things couldn't be more different. Today's aircraft manufacturers generate enormous volumes of data. Using this, the systems engineer is able to develop simulation software totally accurate in its representation of handling and flying characteristics. But this accuracy in software needs to be matched by the simulator's central computer. Today, this has to be big enough and fast enough to cope with the enormous initial software load and to take account of future expansion as additional data becomes available. This is calling for a radical rethink of what has now become a traditional solution. Back in 1976, Rediffusion was the first manufacturer to recognize the current need for 32-bit computing, a need which, throughout the industry, is today regarded as the norm. It is almost a decade now since Rediffusion established the Gould 32 computer as the standard in the commercial flight simulator industry. And with systems in operation now all over the world, no one has more experience of it in use. Indeed, there are few applications for real-time computing that are as demanding as the flight simulator, but with ever-growing demands on computing power, from the growing availability of aircraft data packages, especially during the development phase of new aircraft, from the impact of the FAA's Advanced Simulation Plan, from the use of high-level programming languages. Rediffusion believes that, as a design concept, the mainframe is rapidly reaching the ceiling of its sensible extension to serve the flight simulator industry. Now, Gould has introduced a totally new computing concept, much more appropriate to today's flight simulation tasks. It's called Cyclone, and Rediffusion is again the first manufacturer to adopt it. Cyclone brings a totally new approach to both civil and military flight simulation and has been designed from the outset around the real-time simulation task. Its configuration is based on the use of distributed processors organized into computing nodes. These are linked by a unique high-speed reflective memory system, as well as by a low-speed housekeeping bus. A dedicated data processing node is used to coordinate the real-time nodes and to ensure that there is always the capacity to cope with simulator software maintenance and background processing during training. But Cyclone is more than just the most efficient processing solution. It also offers the ultimate in modular flexibility. Now, this means that exactly the right amount of computing capacity can be specified to simulate everything, from small aircraft types right through to the most complex glass cockpit aircraft of the future.
In service, as more data becomes available or training needs extend, computing power may be expanded simply by adding additional processors, or a complete node. Of course, because the processors are all identical, maintenance is dramatically simplified, and spares holdings can be reduced by at least 50%. Indeed, one node can be included in the system as a hot spare, instantly available to take over the responsibilities of any other component in the system, should that fail.
Cyclone then contains the future because it offers the flight simulator operator total flexibility of application with proven hardware, low cost of ownership, plus the worldwide support of a major computer manufacturer. But it offers much more than that. Cyclone is bringing a new logic to the computing of flight simulation, and the benefits of that are only now starting to be appreciated. Nowhere are those benefits more clear than in integrated queue generation, with Rediffusion already implementing dedicated Cyclone processors to handle the digital control of a simulator's control feel and motion system.
Ultra-low friction hydrostatic technology reproduces all the axes of movement of an aircraft in flight and ensures a smooth, realistic response. Here, as in all areas of the simulator, design quality and reliability are major issues, and Rediffusion goes to extraordinary lengths to ensure that both are maintained to the very highest standards. From advanced CAD technology to fatigue testing components way beyond their normal operating limits, nothing is left to chance. The same thoroughness is evident in the approach to control feel, because it is the only hands-on interaction between man and machine. The accuracy of the simulator's control feel system in representing the aircraft through its entire operational regime is critical in establishing its validity as a training device. That's why in recent years, Rediffusion has progressively adopted a totally digital alternative to conventional analog techniques. That means that inputs to and from the hydrostatic actuators, which in this control loading frame drive the simulated controls, are computed many times faster and with a far greater accuracy than was previously possible.
Of course, because all the relevant parameters are now contained totally in software, the entire system is more reliable. It's self-calibrating, and if in the future there is any need for updates, it is ultimately flexible in operation. It is developments like this which make Rediffusion simulators the ultimate training tools. So much so that in airline operation they have earned the very highest training credits from the international regulatory bodies, plus the endorsement of military authorities all over the world.
In the area of visual simulation, Rediffusion's range of computer image generation and display systems has been carefully developed to support this capability in a logical and structured way. The basic NovaView SP1 night-dusk system has been greatly enhanced by the option of integrated surface texture. Watch once again how height and speed cues are dramatically improved as the optional texture is compared against the conventional SP1 display. SP1T will substantially extend the training capability of a system which already provides the most cost-effective way for civilian operators to achieve the FAA's Phase 2 and its worldwide equivalents. Texture is available for fitting into existing SP1 installations, and for relatively small cost, it will substantially increase the training value of these already well-proven installations. NovaView SP3T allows full daylight training with texture and has met a wide range of both civil and military training needs. SP3 was the first and remains the only system to have gained FAA Phase 3 and has the capability to create fully integrated environmental effects such as snow, rain and lightning. And here is a brief preview of a new Rediffusion visual system launched in 1986. These are the first real-time scenes from SPX, a family of systems, all of which can incorporate texture and which will allow operators to migrate from a basic night-dusk capability through full daylight to the high-resolution system to meet specific training requirements, simply by building on a modular design. A major advance in operational realism is the use of fade level of detail. As scenes develop, so important features gradually become clearer as the system realistically blends in the level of detail it's presenting. And because features like fog are introduced individual pixel by pixel rather than line by line, the ability to create depth in an image is greatly increased. This unique combination of practical features, flexibility and new scene realism will allow SPX to make increased training capability available to all operators at a level of cost previously quite unattainable. Full military mission capability is provided by the highly advanced CT6 visual system. In both air-to-air and air-to-ground sequences, it presents a level of detail which brings true operational realism to military training. With the highest scene density of any computer-generated image system available, CT6 will service all advanced combat aircraft, rotary and fixed wing. Though it depends on new computer hardware, CT6's databases are compatible with earlier CT5, and the system has been created to be used with all display technology, current or proposed. And that means monitor, dome-based systems, and wide. Launched in 1981, WIDE genuinely moved flight simulation forward a generation by displaying for the first time computer-generated scenes of the outside world through a continuous, uninterrupted field of view. And because it has transformed the realism of the simulator, WIDE has gained pilot acceptance and achieved the highest international regulatory credits. Remarkably, over 5 years, WIDE remains unique, and despite competitive claims, it is the only such system to have been operationally demonstrated.
And strobe lights on.
As originally designed, WIDE creates a continuous field of view that extends 150 degrees horizontally by 40 vertically. In its WIDE 2 form, introduced in 1983 to meet the very special requirements associated with mission-oriented military helicopter training, the field of view has been extended to allow a massive 200 degrees of continuous horizontal vision. Now, Rediffusion has introduced supra-wide, using advanced CRT technology to further improve picture sharpness, contrast and quality. And most importantly, scenes are presented with a far greater consistency of resolution. A relatively small cost increment translates directly into even better pilot acceptance, a higher transfer of training, and the potential to meet even more demanding regulatory requirements. As a display medium, WIDE is fully compatible with all large-scale simulators and current or proposed rediffusion image generation technology. To meet a specific military training need, rediffusion simulation has already demonstrated realistic computer-generated images projected across very wide viewing areas inside a dome. This technology, however, requires multiple channels of expensive computer image generation, so much so that the next logical development has been to concentrate the dynamic elements of the scene in the pilot's field of view. Working with the US Naval Training Equipment Center in Orlando, Florida, Rediffusion has built a laser projector-based unit which marries the movement of the trainee's eyes with ultra-fast computer responses and is capable of generating an area of interest display directly in the pilot's field of view. Ultimately, the success of any training exercise depends on the skill and the performance of one person, the instructor. That's why Rediffusion has placed so much emphasis on the design and development of instructor facilities. This, the very latest system, is the first ever to combine touch-sensitive screens with microprocessor control, The ability to communicate with the simulator and call up events is now literally at the fingertips of the instructor. Currently, the screen is showing details of the aircraft's configuration. Fuel up the vertical axis, zero fuel weight along the bottom. In this frame, details of the aircraft's start position can be entered, on the apron perhaps, or in the freight area. Whereas this page can allow the setting up of the cloud base, cloud top, state of the runway lights, and other relevant information. One of the great beauties of this system is that the style and design of the graphics is entirely at the discretion of the operator. Flexibility is very much the key word. Let's put our aircraft right in the center of the map, flying due north, under the influence of a wind of 15 knots from 105 degrees. Let's bring the wind round to the southeast, strengthen it, and commit the system. Let's freeze the display now and reposition our aircraft. Commit ourselves to that. Alter its heading so that we're now flying 42 degrees. Let's introduce some weather. So in the time that the map has been on the screen, we've altered the wind speed, its direction, the position of the aircraft, its heading, and we've given the crew some particularly tricky weather conditions with which to contend. But perhaps the most important aspect of all of this, apart from the dramatic increase in efficiency to the instructor's work regime, will be the total involvement it will now make possible with the crew under training.
Well, welcome back to the simulator, Adrian, Steve. Today's exercise, as I hope you know, involves a loft exercise. We'll be flying a line orientation.
Rediffusion designers and engineers have created the ultimate training environment, in which crews can practice truly operational procedures that would never be possible in the air. Watch this Boeing 767 crew being briefed and then going through a line-oriented flight training session.
And some of them will travel onward to Birmingham.
Once in the simulator, they can be readily exposed to circumstances and emergency conditions they will hopefully never have to meet in a lifetime of flying. In this exercise, a sudden loss of cabin pressure at 30,000 feet.
Can you hear me? Now I can hear you. We've lost the cabin and the passenger oxygen are going to be dry. Okay, understood. And call my 2C. Okay. Master, Britannia 767. Loss of cabin pressurization. Commencing emergency descent just past Mickey, leaving 390 now.
Roger, Britannia 767, that's understood. Scorecard in and scorecard.
Britannia 767, roger the idea you have.
And scorecard for 77.
Britannia 767.
Eagle 1's in on the target.
In military operations, the emphasis is slightly different. Simulation here can reinforce actual training experience, providing a practical parallel to flying, allowing demanding maneuvers, formations and routines to be introduced and developed without risk to man or machine. Full mission capability is now also widely recognized as a valuable contribution to military requirements, with simulation providing experience of weapon systems coordination, giving crews regular hands-on experience of attack and enemy engagement with a realism that is quite impractical in the real world. In military helicopter simulation, Rediffusion has incorporated the first 5-projector wide 2-display system, providing daylight visuals with texture across 200 degrees of horizontal viewing, into this, the Royal Navy's newest Sea King simulator. Watch as the crew use this capability in a truly operational maneuver.
Doctor. I've been asked to do one photographic run around the ship. Are you happy for that before my departure to my mother? 512, roger, and Dr. Care. Am I clear to left eye? Have CO7 on board. 512, roger, lifting to starboard. Okay.
Up to now, flight simulation has been concerned with large airliners and military aircraft. But the growth of regional and commuter airline services, together with changes in international training regulations, have created a demand for a new approach. This simulator, representing the twin-prop Cheyenne 3A aircraft, is an example of the type of advanced technology solution now available to this rapidly expanding section of the industry. Its modular construction means it can incorporate a short-stroke motion system and can fully represent the aircraft's physical and performance characteristics. Lufthansa is the launch customer with 3 of these simulators playing a major role in the airline's pioneering Futura program. As such, these will be the first simulators used for ab initio pilot training. The capability Rediffusion is now bringing to civil and military operators alike is becoming wider all the time. The bond between aircraft and simulator is getting ever closer, as is the partnership between Rediffusion and the market it serves.